digital elevation data to a raster and create contours. Sometimes we receive elevation data as XYZ coordinates in an ASCII text file, and it may look like this. So we've got 3 columns with X, Y, and Z. And what I'd like to do is import this text file into a raster grid so I can visualize it as an image, and then I'd also like to create vector contours. So in order to do that, in Ardas Imagine, I click on the Terrain tab and I choose the Terrain Prep tool. And the Terrain Prep tool is really where I work with a lot of different terrain data to convert between different formats, to merge, split, and also to rasterize. So this is really where we work with all of our different types of terrain data. The first thing I'll do is over here on the 4th icon over, which is called Add DTM to List, I'll go to my terrain folder and I need to change the files of type. Here you'll see a list of all of the different supported formats that we work with in terrain, and you can use a variety of these different formats and bring them all together, merge them all together, or convert them from one to another. You'll see right here at the top there's a 3D ASCII, which is the X, Y, and Z, makes it 3D. I choose my file of interest and click OK. The file is added to the list. Again, if you have multiple files, you can add as many files as you would like to do the different processes. And those processes include merging them together. If you had several tiles of DEMs that you'd like to bring together in one mosaic, you would use this option here to merge them together. If you had a very large point cloud, a last data set that you wanted to split into smaller pieces to make it more manageable to edit and to visualize, you can choose the split option. I'm going to choose surface, so I'm going to create from this text file a surface here and rasterize it. If you would like to choose a different coordinate system, you can. Next is the Rasterization tab, and I want to create an output digital elevation model. So I'm going to call this one DEM. And you can see here the cell size is 15 meters. Next, I can click on contouring. So this is optional. I can select output contours if I'd like to create contours. And again, I can call this whatever I would like, contours. It's going to create a 3D shapefile, and I can decide the root height, index every 5 contours, and the interval. I'll choose 15 meters as the interval. I can choose smooth, and then I can do a different variety of things as removing them and removing closed contours and so forth. I can also do some forms of classification if I would like, so that I can find rooftops, I can find vegetation, and then therefore I can find bare earth accordingly. So I'll do the rasterization and the contouring. If you have multiple ones, you can click batch or you can just choose OK. So as this is processing, we can see it is complete. And once it is complete, I can open the outputs. So I'll open up the raster layer by clicking on Open, Recent, and choosing the DEM, IMG. Here I can see the grayscale of the elevation file. And then I can also open up the vector layer on top of it, clicking on Recent, and there are my contours. So once I display my contours, I can come under the Vector Contextual tab and choose a different style. Maybe I don't want simply just black lines. I want to create a unique value for each of the heights of those contours. So I'll choose a unique value for the attribute of height, generating new styles so that I can see each different height of the contour as a different color. And that is how I convert an XYZ ASCII file to a raster image and create contours. How do I display a die map image? Some of the imagery that you may receive, such as a Spot 6 or Spot 7 image, may come in a die map format. And in order to visualize that imagery, let's look at what it looks like in Windows Explorer. So When you download the data or when you copy the data locally, you will see a folder, and when you double click on the folder, there'll be a few folders, subfolders, as well as some additional files. Now you'll see here that there are quite a few TIFF tiles. Now if we add these individual TIFF tiles into the viewer, they're not going to show any projection information, and they're not going to be associated with one another. So we need to display this DIMAP image as a tiled image that uses the projection information associated with this data set. So how can I do that? If I come into Erdas Imagine, I can right mouse click to open up a raster layer. And then at the files of type down at the bottom, you can either set this to a file of type that you use most often, like an IMG or TIFF. My favorite option is to use all file-based raster formats and then choose the asterisk here, which is going to copy that into your preferences so that every time you look in this particular folder, you will see all raster-based file formats, whether they're IMGs, TIFFs, ECWs. Let's choose the file of type for this specific image as spot DIMAP, and the imagery is going to be in a format called spot and then an asterisk and then an XML, so an XML format, spot DIMAP. So I'll choose spot DIMAP, and then I will double click into the folder, and there you will see the specific data set that I should select in order to display it in the viewer. So I'll select that image. I can choose raster options here to choose the different band combinations before I display it. And then what you'll see is the whole image, all tiles, and then at the bottom here, you'll also see projection information so that I can zoom in and zoom out. I can also use my inquire cursor here to look at any specific pixels in my image, etc. I can show the neighboring values around those pixels as well. So if you needed to see the pixels around that specific digital number value, you can do that as well. So if you just simply drag and drop one of the TIFF files, one of these tiles over display, but it's going to have no projection information, so you can't put these images together and use the metadata that's really associated with the imagery as it should be when you use the actual format of the XML data set for the spot DIMAP image. So that is how you visualize and look at spot and other DIMAP formats.